Hi, and welcome to Island Math. Today we're going to be discussing prime numbers versus composite numbers. We're going to be looking at number sequences, and we're also going to be looking at roots and exponents, specifically square roots, cube roots, and squares and cubes of numbers. First, we're going to start with prime numbers versus composite numbers. Now, for a prime number, that is just going to be any number that only has the factors of itself and 1. So for instance, a number like 3, right? Only 3 and 1 multiply cleanly into it. So this would be prime. Another example of a prime number is going to be 5, since only 5 and 1 can multiply cleanly into it. Now, composite numbers are completely different. Composite numbers are numbers that have more than just itself and 1 as factors. So a number like 8, for instance, 4 and 2. This number is going to be composite. Another composite number could be 24, since you have numbers like 12 and 2 that go into it. You have numbers like 6 and 4, and that is basically the difference. The most important tip is that the number 1 is not a prime number. Although it seems sort of counterintuitive, that is how it is. 1 is not a prime number. And technically, 1 and itself, which is 1, can go into it, but you must remember that this is the one exception. 1 is not a prime number, and you should be fine with these. Next, we're going to go on to an example of sequences. Here we have the most common type of sequence, an arithmetic sequence. And over here is the main equation to find the nth term. So using the nth term equation for any arithmetic sequence, you can just plug in a number for whatever term you want and you will get the number for that term. So first we'll start with this over here. First things first is we find the first term, which is 7. Then we are finding the common difference, which, as we can see, is simply plus 4 each time. Plus 4. All right, using this, we simply write out the equation an equals a1, which is the first term of the sequence, which would be 7, plus n minus 1 multiplied by d, which is the common difference, which we found up here as 4. And you can simplify this if you want. However, this is really the sequence here, and you can basically test it out. So for instance, if I wanted to find the third term of the sequence, I would put 3 in this equation and it would give me 7 plus 3 minus 1 multiplied by 4, and that's going to give me 7 plus 8, which is the same as 15, which is in fact our third term. So using this equation here, if they asked us to find the 100th term, for instance, we would just put in the same thing. 100 minus 1 is going to be 99. So it would be 7 plus 99 times 4. Using the nth term sequence, you will be able to find any term for the specific sequence. Okay, now going on to more number sequences. Now, this is called a geometric sequence. A geometric sequence does not have a common difference, rather it has a common ratio. And this is the formula. A to the n equals AR to n minus 1. Now, this is much less common on the exam, but I wanted to include this because it can come up sometimes. Now, in order to figure out a sequence like this, they are probably going to give you numbers like, let's say, starting with 4, 16, 64, and so on and so forth. Using this as the sequence, if this is the sequence over here, we can basically say that, okay, if 4 is the first term, 16, 64, we can see a pattern of multiplied by 4 right here. And this is basically how geometric sequences work. So instead of adding or subtracting, you're now multiplying or dividing. So if I wanted to find the nth term of this sequence right here, I would say, okay, a to n equals the first term of the sequence, which is 4, multiplied by r, which is the common ratio, which is also 4, to the n minus 1. And this is our equation. And we can test it out. So let's say, for instance, we want to find the third term, which we already know is 64. A3 equals 4 multiplied by 4, 3 minus 1 up here, which is going to give us 4 multiplied by 4 squared, which is 16 times 4, which in fact equals 64. So that's always a great way to check over. Once you remember that geometric sequences are simply multiplication, and you remember that this is the very important equation right here for the nth term, and that once you remember also that for the arithmetic sequence, it's subtraction or addition with a common difference, then you'll be able to properly tackle these kinds of questions. Finally, we have squares, cubes, square roots, and cubic roots. Now, this is a more simple topic, however, it must be covered. So, for squares, if they give me 2 squared, any number squared is simply multiplying that number by itself. So, 2 squared is the same thing as 2 times 2, which equals 4. If I have 9 squared, that's the same thing as 9 multiplied by 9, which is equal to 81. So that's how you deal with squares. Now, cubes are different. Cubes are basically multiplying that number by itself 3 times. So 2 cubed is 2 by 2 by 2, which equals 8. Or if I wanted to do 4 cubed, that's the same type of question, just different numbers. And we're going to get 64. Now, for some of these questions, you might want to be able to memorize some. So like 2 cubed equals 8, 4 cubed equals 64, 3 cubed equals 27, things like that. However, once you understand the principle that whatever the exponent is, that's how many times you're multiplying that number by itself, then you will be able to tackle these questions on your own. Now, for square roots. Square roots are basically doing the reverse of the squaring. So if 2 squared equals 4, the square root, this is a square root sign, of 4 is going to be equal to 2. It's basically just the reverse of that action that you had to do before. Now, square roots can get complicated, however, always remember that it's going to be some kind of value that you're able to find. So it's not going to be a decimal or something. They're never going to give you a square root that results in a decimal and ask you to calculate that. It's always going to be some number that you would have known the square of. So for instance, if they give me the square root of 25, all I have to do is think of my numbers from starting from 1, squaring them up, and eventually I'll figure out that, hey, 5 squared equals 25, and so root 25 equals 5. Finally, the cubic roots. Cubic roots are even more difficult. However, there's only a few common ones that they would really ask. So for instance, the cube root of 1 is 1, since 1 cubed is 1 times 1 times 1, which equals 1. A cube root of a number like 27 is going to be 3, since 3 cubed equals 3 times 3 times 3, which equals 9 times 3, which is 27. So some of the more common ones that you need to remember would be like the cube root of 27 being 3, the cube root of 64 being 4, and you can always basically do the reverse of these equations. So if the cube root of 64 is 4, 4 cubed is 64. If the cube root of 125 is equal to 5, then 5 cubed is going to be equal to 125. And you will be able to do this for any kind of question that you need. And they're never going to really ask you to do this for extra high numbers that you wouldn't be able to really figure out on your own. That's all for this lesson. I hope you enjoyed it, and I hope to see you in the next one.